Good morning. Just want to take a few minutes today to go over a couple velocity word problems. This is in OneNote right now. You have these problems. I'm going to go over just the two on the quiz practice. The idea behind these problems, they'll give you the equation, and the idea with these is primarily to find the vertex, and the vertex of the parabola will take care of a lot of the questions here. So for this, the equation is going to be h equals negative 16 t squared plus 112 t. Again, those equations will be given to you. It's just that instead of x's and y's, we have t's and h's. So this could very easily be y equals negative 16x squared plus 112x. So just the x's that we usually use are replaced with t's, which represents time, and the y's that we usually use are replaced with h, which represents height. So we do know from that negative 16 and from the square term, that's essentially our a value. We know that if a is negative, the parabola is going to open down. So at the very, very least, we know the parabola is going to look something like this. We know it goes through 0, 0, because if t is 0, then h ends up being 0 as well. So we know it goes through 0, 0. And this is going to represent the rocket. So at 0, the rocket's on the ground. It's going to be launched. It's going to go up. It's going to reach some maximum height and then come back down. So really, this key here gives us that ordered pair would be time and height, or your t and your h. So instead of x comma y, we have t comma h. So this vertex here represents a maximum height. So to answer the questions when it says how long will it take, they're looking for a t value. How long will it take for the rocket to reach its maximum height? They're looking for that t value of the vertex. We know that if a quadratic is in vertex form or standard form, we can find a vertex by doing opposite of b over 2a. So let me rewrite the equation here. If we do the opposite of b, which is going to be negative 112 over 2 times our a value, which is negative 16, we go to the calculator. 112 divided by 32 gives us 3.5. Remember, the coefficient of your square term is a, the coefficient of your linear term, the t, is b. This has no c value, or c for this, you could do plus 0 if you wanted to. So c is nothing. But this vertex, we now know is going to be 3.5, comma, we don't know that yet. That's the vertex. And that's a time at which the rocket's going to reach its maximum height. So how long will it take for the rocket to reach its maximum height? That's going to be 3.5, and our units are seconds for time. The second part of the question is, what is the maximum height? That's simply going to be, again, we have instead of an x value, a t value. Instead of a y, we have an h. So it's going to be whatever this height is. So if you remember, to find the y part of the vertex, we simply plug the x part into the original function. So to find the height when t is 3.5, well, I'm going to have negative 16 times 3.5 squared plus 112 times 3.5. And again, a calculator. and we end up getting 196. And that's going to be the maximum height. So these two pieces here are simply your vertex. This is your h comma t. So your height, I'm sorry, not h comma t, but t comma h. So the time from the vertex and the height at the vertex. And the last part of the question, how long until it reaches the ground? They're looking for this time here. Well, essentially when it's on the ground, the height's going to be 0. So set your height equal to 0 and solve. This is like finding your x-intercepts from graphing parabolas. So for this, I believe it factors. If I do 112 divided by 16 in my calculator, I actually get a 7. So I can factor out a negative 16t as a GCF. So then negative 16t equals 0, or t minus 7 equals 0. Here t would be 0, which we know. We know that at t equals 0, the height was 0, or t would be 7. And that's how long it's going to take to reach the ground and be on the ground again. So really, this is just doing your graphing, but the x-intercepts, the vertex, things that you would find normally graphing, those actually have some meaning in the context of this problem now. We'll go through number 2 real quickly. Here we're going to have h equals, again, these equations will be given to you. Negative 16t squared plus 16t. Again, we're looking for a parabola that opens down because that negative 16 in front tells us it opens down. This vertex then is going to be the time at which it gets to its maximum height. So again, how long will it take? They're looking for t equals what? So the vertex, we're doing opposite of b over 2 times our a value. Remember, negative b over 2a gives you the vertex. That's going to be, in this case, 1/2. Or 0.5. Let me replace this. With 1/2. What is the maximum height? Again, that's going to be our h value. So we're going to find that by putting the negative b over 2a value that we just found, the 1/2, in for our t in the original equation. And 1/2 squared is 1/4, times negative 16 is negative 4, plus 16 times 1/2 is 8, gives us 4. For the maximum height. And how long until it reaches the ground? Again, that's just our x-intercept. So we're going to set the height equal to 0 and solve. Again, we can factor out a negative 16t as GCF. We'll get t equals 0, which again, we know in this situation that starts on the ground, or we get t equals 1, is how long until it reaches the ground. So again, just a couple quick examples of using the parabolas and the graphing that we've been doing to solve some max-min problems. So again, this is just the quiz practice. I went through those. You have those on OneNote. There's also some velocity word problems that you have there with the answer key if you want to check. And then there's also some velocity practice, again with an answer key if you want to do some practice and checking. Again, I'll make sure you have those on OneNote. And I think that's about it for now. You guys are doing well. Let me see, guys. and I will talk to you later.